Hello. Today is Monday, March 1st, or Tuesday, March 2nd, depending which period you are in right now. So we are looking at lesson 2-7, Analyze Linear Equations. This can be found on page 133. Our target for today, or for this lesson, is I can write equations to describe linear relationships. Okay, notice the word linear has the word line in it. We've been looking at lots of lines. They're called linear relationships. So I'm going to go ahead and turn the page to page 134. Looking at example 1. Relate constant of proportionality to slope. So remember, constant of proportionality is like unit rate, like per one of something. And then slope, we've been working on, is our rise over run. Okay. It's our relationship of y over x. So the students in Meg's class are building a fence around the class garden. How can they use the pricing for the different lengths of fencing to determine the cost for 50 feet of fencing? So you can see some visuals right here. And before we jump below, because that's going to look kind of confusing right now, I'd like you to just take a minute and figure out, how would you figure out if you know that 6 feet of fencing costs $30 and 15 feet costs $75 and so on? How would you figure out how much 1 foot of fencing is? So then you could figure out 50 feet of fencing. Now that you've had some time to kind of process that and think about that, we're going to go ahead and look at step 1. Now, these steps you are not necessarily going to have to do every single time. These are just here to show you how writing a linear equation comes about. Okay, so step 1 says write the length and cost as an ordered pair. So for example, up here we've got 630. Okay, so this would be ordered pair 630. We've got ordered pair 1575. You can see that one right here on the graph. Okay. And then 24, 120, 24, 120. And then they have a couple other points on the line. Okay. It says graph the ordered pairs and find the rise. So remember, what rise are your y's, and run using any two ordered pairs. Okay, you see 4 on the line. Remember, you can use any two. Okay. So they've got 2 different triangles here. From the first point to the second point, you have a little triangle. And from the second point to the fourth point, you see a little bit of a bigger triangle. Okay. Each one calculating the rise and the run. So once you've done that, or once you're looking at your rise over your run, you're going to analyze the 2 right triangles. Notice that the ratios of the rise over run are equivalent. So the slope of the line is constant. If you think about the word constant, constant means the same, right? Something that stays the same. So for any ordered pair on the line, the slope m, remember m is used for slope in algebra, is constant. So when we write a linear equation, this is key right here, y equals mx. Linear equation, y equals mx. Okay. So you'll see that they calculated the slope. The smaller triangle was 45 over 9. 45 divided by 9, that's the slope of 5 over 1, or 5. Slope of 130 over 26. That's also a slope of 5. So therefore, in the equation, if we're using our linear equation, Meg and her classmates can use the equation y equals 5x to find the cost. Notice m was taken out and substituted with the 5. So therefore, 5 times her 50 feet of fencing would equal $250. That's a lot to process. We're going to go down below into the try it. It's a little bit less here than there was up here, so hopefully it'll be okay down here a little bit. It says write an equation. Okay, I notice this is a line, so that means my equation is in the form y equals mx. M is slope. I need to figure out the slope of my line. Okay. I notice that they're using the y value of 80, so they want to use this point here at 480. And I notice that they're using an x value of 3, so that would be right here at 360. Okay. So if I'm using my slope formula like we've practiced, I've got 80 minus 60 over 4 minus 3. I'm going to calculate. 80 minus 60 is 20 over 4 minus 3 is 1. Therefore, the equation of the line is y equals 20x. Okay. Took out m, replaced it with slope of 20. All right. Example 2. Write a linear equation from 2 points. Linear equation. Y equals mx. M is slope. So I'm going to use 2 points to figure out my slope. We've got a graph of a drone's descent. Okay. A drone descends into a mining cave. The graph relates its distance below ground to time. Write an equation that describes the relationship. Okay. So here's our lovely slope formula. If I look at the work here, I notice that they're using ordered pairs. There's no points on the line. So if this wasn't here, you'd have to pick your 2 points. I know that they're using point 3, negative 750, and 2, negative 500. So I see that they substituted negative 750 minus negative 500 over 3 minus 2. They calculated and got a slope of negative 250, which means in the context of the situation, it's a negative, right? Some of you may have recognized that right away. This is slope due going downhill. That's a negative slope. Okay. So that means the drone is descending at 250 meters per second. So in order to write the equation, we just substitute negative 250 for m. All right. Our last example, example 3, says graph an equation. Okay. So now we're going to actually have to graph it in this format. Okay. A recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. So I know it's 1 cup of raisins for every 2 cups of granola. So right there, that's my rate of change. That's my slope. Okay. So notice in the equation, we've got y equals 1/2 x. Okay. Now it says graph the line by plotting the point 0, 0. So notice we're starting at 0, 0 for all these lines. That won't always be the case, but because these are proportional relationships, it's at 0, 0. If there's 0 cups of raisins, there's 0 cups of granola. Okay, and then we're going to use the slope to plot another point. So this is why I've been telling you to leave slope as an integer or as an improper fraction. These are our directions. Our rise is 1 and our run is 2. It's positive, which means from 0, 0, I would go up 1, right 2. Up 1, right 2. And I could continue that up 1, right 2. I know I'm off the graph, but I'm just trying to make a point. Literally make a point. So slope is our directions. It's how we move from one point to the other when it's a line. Okay. This might be a little bit easier to show you on the try it here on a blank graph. So try it A, write the equation of the line. Okay, I see the word equation, so that's going to be y equals mx. I need to figure out my m, my slope. I need 2 points to find slope. I'm just going to pick 0, 0 because that's usually a little bit easier. And I'm going to look at 10, 4. So I've got 0, 0 and 10, 4. My slope, I'm going to subtract my y values over my x values. And when I simplify, my slope is 2/5. So the equation of this line is y equals 2/5 x. My positive slope matches my positive line. Now try it B. This is where we're going to have to graph. Okay, this is a proportional relationship. So I'm going to have my first point at 0, 0. You need 2 points to make a line. So I've got 0, 0. Now my slope, if I look at my equation here, I recognize that my slope is -3. Okay, so my rise is -3. And you might be thinking, well, what's my run? Well, an integer always has a denominator of 1, so I'm going to put it over 1. -3 over 1. That's a positive 1, so I'm going to go right. Okay, so from 0, 0, I'm going to go down 3. 1, 2, 3, but I'm not going to make a point until I write 1. Okay, rise, go down 3 and write 1. Okay. Or I could go the other direction, meaning I could go up 3 and left 1, because notice it's still going to fall on the same line. And that wraps up the examples for 2-7.